This video file was recorded in Sabunji University during recitations for the CS204 Advanced Programming course as it was given in the spring semester of 2017.
We have our midterm on Saturday, so let's not waste our time and let's try to solve as many samples as we can from previous midterms. So you can basically expect something similar, but not the same, of course, in your midterm, okay? We just want to warm you up and make you feel like you're in the exam in a way, okay? So you should see what you're going to expect for your midterm. Let's start with the examples. We're going to solve the midterm of 2012, some of the most important questions. Let's start with the second question, namely, I think I should zoom it. Okay. I think this is, okay, this should be enough. So, this is our program. We have a main file here and another CPP file called alex.cpp. We include it here somewhere inside the main. First, we want to figure out what will be our translation unit. You remember the pre-processing, the pre-compiling stuff that we did, I think, at the second week? So this is about that, okay? If you didn't understand it, today is your last chance to understand pre-compiling and pre-processing because I'm going to play the role of the pre-compiler, of the pre-processor, actually, okay? So what happens? Those terms, those commands, starting with sharp, are parts of the pre-compiler, okay? The CPP file that is going to be executed, they will not be there, okay? And we will see which part will stay, which part will not stay, and how we are going to evaluate them, pre-process them, basically. So what pre-compiler does is the following. It takes this main file and everything that is included there, including the IO stream, the namespace, this Alex CPP file here, which we have included there. It's doable, by the way, although we're used to include files in the beginning, and this is how you should do usually, but you can include them wherever you want, okay, and whenever you want. So that takes those guys as an input, okay, it processes them somehow, and as an output we have something that we call the translation unit. And that translation unit is going to be compiled, actually, okay? So we have a kind of compilation before compilation. And I'm going to play the role of the pre-compiler, but firstly, let me show you the output of this CPP file, and we will see that the output is going to be the same, okay? So, we'll start with a new project. You don't have to do it, you don't have to write anything. You'll have the videos, of course. I'll try to upload them today, so you can have them for Saturday. And you just have to pay attention and understand what is going on. So, we have the CPP file here. I'm adding it. And you see I'm including Alex CPP. Of course, it's going to be highlighted to red now because I don't have it here. But afterwards, I'm going to take Alex CPP from here. I'm not going to make another CPP file. I'm just going to copy-paste this guy. So instead of this Alex CPP, I'm going to copy-paste the Alex CPP file from the document file. I'm going to compile it, but of course, I want to see the output. So system pause. Let's see the output. Let me arrange it so in a way we can see what's going on. You see some part of the code is not highlighted, and you can figure out why, and I'll tell you why. So I'm going to execute the file. It's going to be pre-compiled first, then it's going to be compiled. The output is, oh, the system pauses after return 0. Sorry. Again. So let's see the output. Output is 10 and 12. if you can see it. I'm going to enlarge the font. Now let's see how did we get that. Okay, so 10 and 12 is our output. Now let's play the role of the precompiler. Let me do it here in a new Word document. So let's go to our document file. Let's copy paste this guy. Let's paste it here. All right. Now, instead of this guy include alexa.cpp, I'm going to copy paste this part here to the new file, and I'm going to play the role of the preprocessor. I want to arrange the code so it's more viewable. Okay, this is it. I'll start. Of course, this include IO stream is going to be also substituted with the corresponding code of the IO stream file. And the namespace also, but we don't have it here. We don't care about that. We care only for the part which is inside the main. So I'm defining here Haji 10. Wherever I have Haji, I'm going to replace it with 10. Okay? So I start here. Do I have Haji here? Yes, I have it here. So instead of Haji, I'm writing 10 here. And this is it. Okay? Then I'm going here, and I'm evaluating those two if defined and if clauses. And I'm saying if Haji is defined. Is Haji defined? Yes, it is. We have it here. That's why this will be evaluated to true. And we will have this A is equal to 12. Okay? That's why. After the preprocessing, this is actually what I'm doing, the preprocessing stuff, we will have this A is equal to 12. Now I'm defining Serjan 3 plus 1. Wherever I have Serjan, I'm going to substitute it with 3 plus 1. So here, instead of Serjan, I will have 3 plus 1. Exactly as it is. No brackets, no parentheses, exactly as it is. Okay. This is not dealing with preprocessing stuff since we don't have the sharp sign there. This is a normal if-else statement. So it will say there. Then I've defined here Alex, you see? And I'm saying if and defined. That means if Alex is not defined, but is Alex defined? Yes. So is this true or false? It's false. It's saying if Alex is not defined. But Alex is defined, that's why it's false. So this cout statement, of course, and those if and if statements also will be deleted. Previously, you remember this guy, A is equal to 12. It was not deleted since that if clause was true. But this if and if clause is false. That's why I'm going to delete it. And afterwards, I'm going to delete everything that is related to those definitions of those variables. Okay? And this is what we have. Okay? Now, this is our translation unit. Okay? This is going to be our release CPP file. Okay? And the compiler is going to compile this guy here. Okay? So what will be the output of this stuff? Let's do it first logically, and let's compile it. We define A to be 1, then A is 12. This is it. Then we say if this guy is true. Is this true or not? No. 1 multiplied by 2 is 2, plus 3 is 5. 5 is greater than 6? No, it's not. That's why Bir Baruch Day will not be printed. Then we go out, we print 10. We print A. But what's the value of A? It's 12. Okay, and this is it. We actually got this result previously, if you remember. Okay, we got it here. It's 10 and 12. And as you can see, this stuff is not highlighted. It's not highlighted since this if-else statement will be evaluated to false, so it will be deleted. Okay. Now let's copy-paste this part here. And let's see the output that we will have here. Of course, I'm going to write system pause again to see the output. So it's again 10 and 12. we didn't have any pre-processing stuff. Actually, we did because of this IO stream, which was copy-pasted. And the output was, again, 10 and 12. Any questions? No questions. OK. Let's go with another example. Expect pre-processing, pre-compiling stuff to be in your exam. The third one. We have, what is this? A matrix, okay? An array of arrays, which is a matrix. It's actually a dynamic matrix that we dealt with 2 weeks ago, okay? If you remember. Here we have a structure, and inside that structure we have a string. And we have, what is this? A pointer? Only a pointer?
No.
It's what? This is what? It's a pointer. What about this one? Pointer to a pointer. Okay, so you remember when we were dealing with dynamic matrices 2 weeks ago, we had something like this. We had a matrix which was a pointer to a pointer. And how do I know that it's a pointer to a pointer? Because we have 2 stars in the beginning, which was pointing to the first block. Okay, so this was index 0, index 1, 2, and so on. Okay, and then we had the pointers here, and they were pointing to concrete arrays of integers. Let's say this is a pointer to a pointer of integer, and we have the integers here. Okay, so this is what we did last week. Actually, 2 weeks ago. Index 0, 1, 0, 1. Now, our job will be the following. A, write the node structure definition for the node at the left-hand side of the figure. So we have to write the structure definition of this node here. And what did we have inside? We had a string and a pointer to a pointer. Okay? So matrix was a pointer to a pointer, and it was pointing to the first block. Okay? And can you tell me, okay, let's deal with this first, and I'm going to explain it again. So, can you tell me how we are going to write this structure here? Only this structure. Let's say the name of this pointer here is matrix. Not the movie, but the pointer to the pointer. So, we have struct. This is a structure. Let's give this structure a name. Let's call it node. What do we have inside? String. Let's say that the name of that variable, of a string variable, is name. And what else do we have? We have pointer to a pointer of what type? Integer. Matrix. Let's call that pointer matrix. So this is our structure. Okay? Now, we have also an array here. Yes, you're right. But if you do it in your exam, probably will not shout to you why you didn't. And will not take points from you. Because this is what matters. But you're right, yeah. Okay. We have another problem here. Here inside this structure, let's say that we have a constructor. Let's call it node. And this constructor takes 2 parameters. X, which is integer, and it takes also y, which is an integer. Okay, I'm going to change my battery now. I'm sorry. If you want to have your videos, I have to change my battery. Do we have, is it okay now? Yeah, okay. So we have 2 parameters, x and y. X is the number of rows. So basically, this is going to be x minus 1, number of rows, and y is the number of columns. So this is going to be y minus 1, y minus 1, y minus 1. Okay? Our job is the following. We have only the name and the pointer to the pointer called matrix, and we are going to write this function node. So we will have this structure here. The matrix is going to point to the first array here, the first element of this array, and we are going to dynamically allocate the other parts. How are we going to do that? We did it actually, if you remember, last week. You remember that stuff? Can someone do it? Kind of. I'm sure that if I give you like 5 or 10 minutes, you can do it. It's doable. Or if you have your cheat sheet, you can do it. I'm going to erase this stuff because I need this part of the board. But you remember the structure, and inside the structure we have this constructor. So, I've declared the function inside. I'm going to define it outside of that structure. That's why I'm going to write, the name of the structure was node. So node, 2 points, 2 points. Since we're dealing with the structure, the name is the same, node. And it takes 2 parameters, x and y. Now, before writing the code, if I want to access always the pointer to the pointer points to the first element here, okay, to the address of the first element. If I want to access the second one, how can I do it? So this matrix, I want this matrix to access this guy here. Let me write it better. I want the matrix to access, let's say, the second element here, which is also a pointer, as you can see. So how can I do it? We have 2 ways of doing that, at least 2 ways. Yes?
Pointer plus 2.
Matrix, then, in brackets 2, or is this what you were, or plus 2 you said? You're right, actually. You can do matrix 2, you can write something like this, and yes, you are dealing with this pointer here, okay? You can also say matrix plus 2, and then this guy, this matrix pointer to a pointer, points here. But if you want to access the value of that guy, then you just put a star here, and those 2 definitions are basically equivalent. They're doing the same thing. They're pointing, not pointing. They're actually this value here, okay? Of course, if you want to access this guy here, this one here, I can do it in a faster way, like this. Matrix, what's the row? The row is 1. Or let me do it here better. I want to access this guy here. So the row is the second row, actually the third one, starting from 0. Starting from 0, this is the third one. So matrix, row 2, column 1. If you want to become crazy, you can use this notation also. Yes, you can do it. And I'm not going to write it here. You can ask me during the break. Or if you want, I can write it here also. But it's doable, okay? So you already have it here. And if you want to access this guy here, you just add plus. So matrix plus 2 is basically pointing to this guy here. Okay? If you want to point to the next element or any element here, plus I, you put another bracket, star, and this is it. Okay? Let me write it also. So, matrix plus 2 star, we are pointing here. This is another pointer. So if you want to point here, we can do just something like this. Plus 1, we are here. But the pointer is here. We want to access this value here. So we have another star. This is it. Those 2 guys are also equivalent. I'm doing it since I seriously seriously expect to have something like this in your exam. Even more complicated in your midterm, okay? So pay attention to this stuff. Now, our job is the following. We have x and y, and we want to dynamically allocate x rows of pointers, of integer pointers. And for each of those pointers, I want to have another y rows, or actually those are columns. So how am I going to do that? First, of course, I have to allocate memory for this one. And this is an array of pointers, of integer pointers. That's why I'll have here a counter first. I'll allocate, and it's going to be done dynamically using the new statement. I'll allocate x elements of integers in the following manner. Matrix. So matrix was the name of the structure, the pointer to the pointer, you know. So we had here a string, and also we had this pointer to a pointer, and this was our structure, okay? So this matrix is going to be equal to new. When I say new, something is going to be allocated what? Integer pointers. So these are pointers, and we need an array of integer pointers. How many do we need? X, from 0 to x minus 1. So we are done with this guy here. Now for all of the rows, I'm going to dynamically allocate another array, but this time of integers, not of integer arrays. So how am I going to do that? With what? With a loop, let's say a for loop. I'll start from the 0th index, from here, till x minus 1. So for I is equal from 0 till x, smaller than x, I increment it by 1 in each iteration. Now, what I'm going to do? I'm trying to access matrix of 0, then matrix of 1, matrix of 2, and then, or matrix of I, matrix of I is equal to what? New, help me, int. Exactly, because those are not pointers anymore, those are integers. So we have here 5, 9, 3, 2, 11. But here we have addresses, okay, pointing to this address. Okay, so if the address of this guy is, let's say, EA0, we have here EA0. If this is CB7, this is also CB7, and so on. So this is new int of y. Well, this is it. And also, I forgot I should put the string to be CS204. And the name of the string was name, I think. So name is equal to CS204. This is it. Pointers, integer pointers, integer. X rows, Y columns. Any question? You will have the solutions. If you don't have them, just mail me. You'll get them. If this is understood, also the structures have their own constructors. Maybe we haven't seen them before. We have seen constructors only with classes, but you can put them with structures also. I think it's a feature that has been with us in like 10 or 15 years or so. I think previously it was not doable, but you can do it now. So in a way, the difference between the class and the structure is diminishing, but there's still a difference. There are different entities. Let's go with the fourth question. Where is the fourth one? Okay. C. So you remember there are certain clauses, there are certain statements. We use them to assert that something is not going to happen. Okay, let's say if you didn't want to divide by 0, we asserted that the denominator will not be 0. If it happens, the program is going to terminate, but in a polite manner. You will not have something like error fatal error or something like that. You said, okay, something bad happened, and we know why the program terminates. It's like if-else statements that you should evaluate. So let's choose CI. For which values of x does this statement cause the program to abort in debug mode? And this is highlighted. We will see why. Explain your reasoning. So for which statement the program is going to abort, to terminate? X? X greater than 13. What about 13? It will terminate. So if x is equal or greater than 13, the program is going to terminate, because we want to assert that x is smaller than 13. If this is not the case, if this is not true, the program terminates. Okay? But it's in debug mode. What about in release mode? You remember the debug mode, when you are still writing your code, you are using the debug mode because you want to find bugs in your mode. Okay? But when you are over, you don't have any bugs, you want to release it to the public, then you compile it in release mode. Okay? Of course, it's still going to have bugs, but not the bugs that you have found. Okay? So the poor users are going to be used as experimental mice. So they are going to find the bugs for you. Okay? Something like Microsoft is doing, and you are going to report the bugs. So in release mode, what do you think? If we have this assert statement, what's going to happen? When it is going to abort the program? Who said that? It won't abort because why? Because of?
The assert statement is not read by the compiler.
Exactly. The assert statement is kind of preprocessor that is you can use it only in debug mode. In release mode, the compiler doesn't take it. It looks at them as it is a comment. Okay, it's not going to be evaluated. So in release mode, even if the value of x is equal or greater than 13, it's not going to terminate. So you're correct. Yes. Assert statements apply basically only in debug mode. Okay. Let's go with another question. Is this clear so far? Okay. Question 5. Read the question, try to understand it. Since we have like 20 more minutes to finish, take your time. Feel yourself as you're in exam, but much more relaxed, since you're not. Read the question, try to understand it, and try to at least come up with a solution, not a code, a solution. While I'm erasing the board. Excuse me? No, it's not mentioned to be a circular, I think. Only doubly. If you don't see, I mean, it's a good remark. If you don't see here anything about circular or non-circular, don't complicate your life. Make it easy. Okay? So it's non-circular, basically, because we don't have any word circular list here. So let's see what the structure is doing. We have here a node. This is the definition of the structure. And I'm going to write it visually. We have here the next pointer. It points to another node. And we have here the previous pointer. It points to a previous node. Inside we have the info, which is integer. And it's basically not a matter of concern in our case here. Our problem is the following. Could you understand the problem or not? Yes or no? So, can you explain it? Simply linked list, yes. So we have a simply linked list. From that simply linked list, we want to create a doubly linked list. Can you do it? You want to write the code? Okay, you can do it. Very nice. So this is our problem here. We are sure that we are using this structure here, which is a node for a doubly linked list. But we have something like this here. This is our problem. We have those nodes. But those pointers to the left, the previous pointers, are not set. Okay? They might point to null or might point to somewhere that makes no sense. But not to the really previous node. But the next pointers are okay. So we have something like this, and this head is not part of a class, because if it was a part of the class, we would have something like this in private. We have the head, and this poor head is pointing here. And then we have the member functions. No, this head is only a pointer in main. You can assume something like that. Okay? So our job is to convert this simply linked list to a doubly linked list. We have the pointers. And furthermore, the function should return the tail, meaning this node here, the end of the list. Okay? So somehow, we should iterate it and make those pointers, this guy point here, this guy point here, this guy point here, and in the end return the address to this node, which is the tail. So we have the head and we have the tail. Can you do it?
First, we can create a temp or two.
Temp pointer to?
Equal to head.
Exactly. Let's do it. So we have temp pointing to the head. Then?
We can use head next.
So head next. Pre equal to temp. Very nice. Your friend is saying we are going to do this. Temp next, which is here. Previous, which is this pointer here, is equal to what? This is equal to temp, yes. And then temp next. Oh, okay. So temp comes here. Temp. You can do it. Very nice. Temp is equal to temp next. And again, here you do the same thing. Temp, this is temp. Next, we are here. Previous is this one, is equal to temp. Temp is pointing here, so this is here. Is everyone getting the logic or not? Okay. Also, this guy is set. This guy is set. And we should also check while. What? While?
While temp next is not.
Exactly. While temp next is not equal to null. Do this guy. Okay, because if temp next is equal to null, we cannot do this stuff. So basically temp will terminate here. And what else? We should return the tail, which is temp in our case. So return temp. This is it. Head previous is equal to null. Yes, you're right about that also. Let's write it. Very nice. But what if head is null? We should check if head is not equal to null. Then, so let me write it here. If head is not equal to null, because it might be null, then we might say head previous is equal to null. Then here we declare that node temp, which is equal to head, and the name of the function in the end. Let's put it convert. Let's say the name is convert. We take the head as a parameter, which is a pointer to a node. And what do we return here? Node's pointer also, which is temp in our case, which is the tail, actually. Node star. Is this clear or not? Actually, this is not the solution that you are going to receive, but I'm really happy that you came up with the solution by yourself, because our solution uses 2 pointers. Namely, we are using temp, let's say, and not temp points here, and previous. Previous initially is null. This is null. Put temp points to the head. And I say temp previous is equal to this guy here. So if this is null, it's also null. Then I make this guy point here. This goes here. And I say this guy previous is equal to this one. Then this one comes here. This one comes here. This guy previous is equal to this guy. I said it. This guy comes here. And so on up until I reach the null. So I'm using 2 pointers. But here we have done it with 1. And I think this is a better way of doing things. Since if it's not complicated for you, it's better like that. How many of you understood this example? Very nice. So, this is the function. The name of the function is convert. We are taking as a parameter pointer to a node, which is our head to the list. Okay? And inside this is our function. I'm sorry because I didn't write this one. Okay, so this is for the function. We are closing the brackets for the function, okay? If head is not equal to null, it's okay now. Nice. Well, I'm afraid you should all take A's in your midterm. Hundreds, I mean. If you go like this, that will be a nice thing to hear from you. Let's go with this example, and it will be the last example for this class. What is the output of the following program piece? Do we have a hero that can come here and write it? The solution.
I can try.
You want to try it? You're going to be recorded.
Okay.
Okay. Try to do it. I think it's doable. You want the red one or the black one or the black? Okay. I'll have a seat here. If I have questions, I'm going to ask you a question. Okay. Well, I think you should have the mic because you are the TA now. Take it. It's not easy to be a TA. Trust me. I don't think it's easy to sit here, okay?
Okay, so
I'm going to do some Facebook while she's saying
and
we have the 0, 1, 2, 3, 4, 5 because of the for loop.
yeah,
Yes.
and P points to here, A plus 1. Am I wrong?
Yeah, it's okay. Yeah, you're right.
So it says,
Starting from 1 to 5,
okay,
I'm printing
P plus I.
3p plus I plus 3p plus I.
So first I is 0, P plus I.
The index is on the way. Index 0 means
Okay,
it's better than that. Yes. So,
I'm confused.
no, you're right. You are going the right direction.
Okay, p
So
plus
p
I. P plus 0 is...
Why did you define a variable I?
Okay.
Initially, this is 1.
No, it's 0.
It's 1. Oh, it's 0. Yeah, I'm sorry, it's 0.
So p plus 0 is 1.
Yeah, and a plus 1, a plus I is how much?
A plus I is 0.
0 plus 1. Okay.
So C out is
You can
1.
write an output. Yeah, output. See out. Okay, this is 1. Very nice.
Okay.
Then increment I by 1. Okay.
So 1 and 2,
Yes.
I think. It's 3. And then it's going to be
Increment I now.
3 and 2.
Exactly.
So it's 5. And then it's 4 and 3,
Yes.
7. And 5 and 4,
Which is?
9. And that's it.
Okay, very nice. I'm going to go through it again. Nice job. You're not going to get the salary for that, but you tried. I think it can be counted towards your internship. You never know. Okay. Should I go through it again or not? Understood? From all of you. Very briefly, for the guys that are going to watch this through our video. So we declare an array called A. And this A is a pointer to the first address. Basically, if the first address is 100, the value of A is going to be 100. We have 6 elements. With the for loop, starting from 0 to 5, we are filling those values with the corresponding index number. Okay, so index 0 is 0, index 1, 1, and so on. Then we define another pointer here, which is equal to a plus 1. But a plus 1, you see this is a pointer, and we're dealing here with pointer arithmetic. So what do you think? What is going to be the address of this guy here? We are using integers here. 104. So P is going to be 104. If you have any problems with this 104, there is a video file about pointer arithmetic, pointer arithmetic, yeah. I think it was during the 2nd or 3rd week. You can check it. So we are not dealing with normal arithmetic here, we're dealing with pointer arithmetic. If this is 100, 100 plus 1 in terms of pointers is the next integer in the memory, and that guy is 104. Okay. And P is equal to a plus 1, which is 104. Now I'm going to the next for loop, starting from 0 to 4, and I'm printing this stuff. P plus I plus a plus I, the value to which P plus I is pointing, added with the value to which a plus I is pointing. Okay. Initially, when I is 0, P is pointing here, that's why, or P is pointing here actually, that's why I have 1. And A is pointing here, that's why I have I plus 0. When the I is incremented, so we are here now, when I is incremented to 1, then P plus 1 actually is index number 2, that's why I have 2 here, the value to which it is pointing is 2. And A plus 1, which was here, actually now points to index number 1, that's why I have 2 plus 1, and so on. Okay? And I have the output 13579. If you don't trust me, do you trust me? Yes. Or I remember a guy like 2 years ago, something like that, told me I don't trust you. So I had to prove him that I'm correct. And I did something like this. So let's execute the code and let's see the output. If we don't get the same output, it's not my fault, it's your friend's fault, because she solved the question, but she's right. 13579. 13579. Any question? Okay, you can take the break of 5 minutes and we'll be back.